All right, number 10, we want to find the approximate points which the given function is equal to the average of the given interval. So we are first going to start by finding the average. We are going from 0 to pi over 2. So we're going to have 1 over, and then it is negative pi to 0, so we're going to do 0 minus a negative pi, which will be plus pi. We're going to do the integral from 0, or negative pi to 0. And we could flip it, but I'll just leave it as negative pi to 0. It'll just come out negative. And then we're integrating. I'm going to go ahead and pull the negative pi over 16 to the front. And so this will be sine of x dx. All right. So we are integrating from negative pi to 0. 1 over upper limit, which is 0, minus the lower limit minus the negative is plus pi, so it ends up being positive. And then the coefficient out front, negative pi over 16, put that in front of the integral, and so we're just integrating sine. All right, so when you think about integrals of sine, think about going backwards. What did we start with to get here? And so we know the derivative of sine is cosine, but going backwards, derivative of cosine is a negative sign. So we would have to start with a negative cosine to get positive sine, because we're going backwards. So we are going to end up with 1 over positive pi, and then negative pi over 16. The pi's will cancel, giving me negative 1 over 16. And then the integral is negative cosine of x, and also you can use the trig cheat sheet to verify. And we are evaluating this from negative pi to 0. When we plug this in, negative 1 over 16, negative cosine of 0 minus a negative cosine, which will be plus cosine of negative pi. And then if you think about your unit circle, onto these angles, 0 is here. The ordered pair is 1, 0. Cosine value is the x coordinate. So this is just 1. It'll end up being negative 1. Negative pi, if we went backwards, would end up here, which is the same as positive pi. Ordered pair is negative 1 and 0. The x coordinate is negative 1. So we would get a 1 here, but it would become negative, and we would get a negative 1 here. So we're looking at negative 1 over 16, negative 1, and then this would end up being a negative 1, so minus 1 again. So we get a negative 2. Negative times a negative is a positive, so we get positive 2 over 16, which is equivalent to 1 over 8. All right, so this is the average. We want to find where the average is equal to the function. So the function is equal to the average when x is equal to what? So we're going to graph this, and we're going to find the intersection to find out when they're equal. So basically we want to know, if I were to solve by hand, which I'm going to use a calculator, but if I was to solve by hand, we would be looking at negative pi over 16 times sine of x, and we would set this equal to 1 over 8. Now we might not be able to get the exact answer by hand, but I can at least show the process. We would multiply by the reciprocal to get rid of this, so you can say divide by, but multiply by the reciprocal. So we would end up with sine of x is equal to 1 over 8, and the reciprocal would be times 16 over negative pi. And then this would reduce to give us 2 over negative 2 over pi, so we have sine x is equal to 2 over negative pi. And then we would do inverse sine to get x. So x would be sine inverse of 2 over negative pi. Okay, so this would get us close, like an answer by hand, but we are wanting to round to 1 decimal place, and this gives you 1, but there's usually two values because of properties of symmetry. Let me see, and we don't have this exact value 2 over pi to be able to solve both. So it'll only give us close. What am I looking for? Yeah, I want the calculator. Let's go to y equal. We're going to graph our original function. So I'm going to say in parentheses negative pi over 16 times sine of x. Okay. So this is our function, and then we are wanting to restrict between 0 and negative pi, so I will change the window. But I also want to get my average function, and my average was 1 over 8. So I'm going to say 1 divided by 8. So I'm going to graph both of these. Let's change my window first. So we want to go from, let's just say negative 2 pi. Let's go a little bit further than what we need. Negative 2 pi, and then a little bit more than 0. Let's just say pi over 2 in the positive section. Second pi divided by 2. So using angles from the unit circle. And then we can still let the height, let's go a little bit bigger than 1. Let's go negative 2 up to 2. And then we'll graph this. So this is what we see. And then let me zoom in. This looks really weird. Let's zoom in this area. Okay, so we kind of see it's crossing twice, and we'll find the intersection. So if we do second and then calculate, and then we can do 5 for intersection. I'm sorry, let me do that again. Second, trace, we're going to do 5. I think I hit the wrong button. It asks you first curve, and it's on the y1 equation. Hit enter. It asks you second curve. I'm just going to hit enter. It says, do you want to guess? You don't have to guess. I'm just going to hit enter, and it will put me on one of those values. So one of those x values is negative 2.45. So one of those x values. And then there's another one. So I'm going to do this again. Second, trace for calculate, option number 5. And I'm going to just arrow over closer to the next point. Now, since I zoomed in, it may not be showing, but I'm going to hit enter, enter, and enter a third time. So it's only picking this one up because I zoomed in too far. So I'm going to zoom. If I do zoom 6 standard, that's way too far. Let's do zoom in. Maybe it won't do too much. We're on the left side over here. Let's see how close it gets us. Okay, I can see both of them from here, so let's do that again. Second, trace, option number 5. And I'm just going to move over closer to the second intersection point, and just hit enter for first curve, enter for second curve, and enter for guess. and it gives me an intersection of negative 0.69. Okay, now if I were to use what we got by hand, it'll give us one of those answers. So if I do inverse sine, it's in blue, second inverse, and I'll do negative 2 divided by pi. Okay. It gives me one of those values, so that negative 0.69, we get that one, but it doesn't give us the other one. It's giving you the first angle on the unit circle, so like that first section, it doesn't pick up that other one. So we got to know how to. I think we learned, might have been a pre-cal thing, but the term is escaping me right now. Corresponding angles, I'm wanting to say, and you'll know how to rotate and plug in that other value to get it from there, like plus 180 or plus, I want to say we do 90-degree angle, 90-degree rotation. It's different for each term. I'll have to go back and review it, but that's how you could get the second one if you want to do it by hand. But we are going to round to one decimal place and separate each answer with a comma. So we're going to do negative 2.5 and then negative 0.7.